Welcome, everyone. Thanks for joining us today at CalicoCon for the session about how Box automated their Kubernetes multi-cluster security policy generation with keeping the GitOps principles together. So as we know, a lot of people have now gone and adopted GitOps, and they are using and applying it for their Kubernetes environments. It's an interesting topic for us as we were talking to Box, like how you can bring the security concept and marry it with the GitOps principle. So with that, I will introduce Tapas Mohapatra. He basically has given us some time to talk to us about this journey which they went through, and it's pretty interesting. So Tapas, up to you. Please introduce yourself.
Thank you for inviting me into this discussion. I joined Box a little over 2 years ago. I manage the site reliability engineering for Box and the capacity and performance engineering. So one of the responsibilities for the site reliability engineering organization is to ensure that Box operates with 100% availability and maintaining all the security and network compliance aspects that we commit to our customers. As part of the team is also responsible for one of our largest platforms that operate over Kubernetes. So that's what we do. We are a multi-cloud company.
So can you tell us a little bit about Box?
Yeah, Box, listed as Box in NASDAQ, is the content cloud. It's a single platform that empowers organizations to manage the entire content lifecycle, work securely from anywhere, and it integrates across best-of-breed apps. Box was founded in 2005. It's been since its beginning, it's been a cloud SaaS-driven organization. With a unified goal of simplifying the content journey for every customers or every enterprises. How do we pioneer in the way how we operate in bringing all those contents, providing a unified experience to all the entire enterprises, and most importantly, with a highly secured infrastructure where enterprises can safely operate over any type of content, starting from projects to contracts to any FedRAMP related content as well.
Awesome. So can you tell us a little bit like how did your group or Box cloud native journey started like, and where did the Kubernetes come into the play? Because Box started in 2005 and Kubernetes comes approximately 10 years later.
Yeah. So like any other companies back then, Box, when it originally started in 2005, we started with the intention of being a cloud native and SaaS organization. So that was always in the Box founders' blood to begin with that mindset. So when originally we started, like you rightly mentioned, Kubernetes was not even born. Microservices was probably in the dreams. Like any other organization, we started with monolith. Pretty early, we realized that it's not going to scale with the scale we wanted to operate in as we went into the market. So our journey started right early days when Kubernetes came into play. Box had been one of the pretty early contributor to the Kubernetes community. If you know a kubectl that everybody uses was contributed by Box in the early days.
Interesting. Okay.
So you can imagine, our journey, it pretty much began when Kubernetes originally was born. So we were a pretty early adopter of Kubernetes.
Can you tell us a little bit about your deployment and the footprint of Kubernetes in your environment?
We operate today in a hybrid cloud environment. So, of course, that means we are in multi-cloud, public cloud, and as well as we have presence in our co-located data centers. We operate two types of Kubernetes models. One is self-managed Kubernetes clusters in our co-located data centers, and in our public cloud infrastructure, we operate, cloud-managed Kubernetes. So overall footprint-wise, you can say we run roughly little over 300,000 cores in terms of the infrastructure footprint. Our clusters are, anywhere sized between 1,000 nodes and beyond.
Got it. And a little bit about what type of orchestrators or Kubernetes environment. You said multi-cloud, but any specific EKS, AKS, Rancher, OpenShift, or anything like that?
We use cloud provided standard Kubernetes like GKE. And then on top of that, because it is a multi-cloud and that includes both self-managed as well as cloud-managed Kubernetes. So essentially, we have developed our own orchestration mechanism to operate in both the clouds. Like I stated in the beginning, our journey to Kubernetes started much before GKE or EKS were born. So we built the orchestration well before, using the declarative languages that were available back then to do the orchestration. So we just naturally enhanced that as we went into the public cloud.
Nice. Okay. So as you have been early adopter of Kubernetes, and we are in a security focus conference here, can you tell us a little bit about what are the security and networking challenges you have faced with Kubernetes?
Once we went into Kubernetes, we actually opened up the infrastructure for services to come and go. So we went more into a single source of control to a microservices world, where services can come and go, scheduled, descheduled very freely. So you lose the control with respect to the compliance aspects. We had challenges with respect to how we operate over the network CNI, troubleshooting network connections between services to service. So thinking about thousands of microservices operating in a constant mode in a changing environment, managing their communications, maintaining security across all those services was a challenge in the beginning. So we started with the native networking model with Kubernetes, but very soon we realized that we are losing, while networking in general worked out of the box, but we lost our troubleshooting ability. We lost the ability to provide granular security and controls around zero trust security policies. So there were ways, but it was very much time consuming for us to develop those technologies in-house. Instead of focusing into the real product, which is why Box was known to the enterprises.
So can you tell us a little bit about compliance challenges? Are there any particular requirements, organizational industry frameworks you're talking about here?
One of the key differentiators that Box brings to the table for all enterprises or all our customers is security. We are a security first company. So what that means is we always ensure that every content that gets into Box network is highly secured and adheres to all those compliances like PCI, SOC 2, and FedRAMP High. Box is a FedRAMP High compliant company. So what that means is we have to always ensure the underlying infrastructure that we run, underlying orchestration technologies that we run is all compliant to every FedRAMP high or PCI requirements. So that requires constant auditability of every network policy that goes in, along with all the communication channels, ensuring that those are periodically reports produced for the compliances.
And this is across that 300,000 cores you're talking about, and the clusters which have like 1,000 nodes beyond.
Yes, so it is not just one cluster. It is, we are talking about, I can't give you all the numbers. Yeah. It's a significant size that we're talking. So roughly, you can say around 6,000 to 7,000 machines that we're talking. Yeah. And running the compliance is not just necessarily at the orchestration layer, rather at the service layer as well. Are the services compliant to all those requirements that comes from the FedRAMP and other compliance departments?
Interesting. So another thing which you talked about or mentioned right now was the zero trust. So I understand the zero trust is being used very much nowadays for everything in the world out there. Like we have ZTNA 1.0, ZTNA 2.0, whatever. But in this context, right, for the workload, can you tell us like what does zero trust mean to you and Box?
Simply put, zero trust for Box is essentially, even if I manage the infrastructure, we should have policies and compliances in place, or the tools and systems in place that will make those validations, even if I'm a Box employee attempting to connect to an infrastructure. So the journey for zero trust begins with least privileged model. Okay. So that's the starting point. So anything that we do in any infrastructure has to be least privileged, granular to the point which is an actual requirement, well approved from the different security, GSO, and compliance departments. That's from where our journey begins. Now, from there, we want to identify different layers of trust, right from the layer 7 all the way down. So the services to services, they communicate, like starting from the external, getting into the Box infrastructure, and then once somebody enters into the infrastructure, then how they go all the way down, including the internal service to service communication, is very well controlled to ensure that the communication from one service to the other service just happens over, like, for example, MTLS, or like, only the necessary mandatory ports are open for services to services, even though they flow within the internal network itself. So that's the level of trust boundary that we follow when it comes to having packets flow through external all the way through within Box.
Interesting. That's a really good information for everyone else, for us to know, like, okay, what does zero trust mean with respect to the workloads? And then when you have so many of clusters running so many nodes and so many services, like that's the least privileged model, which basically should be used with respect to making the communication secure. So as you have talked about such a large footprint, and you basically hinted on like a lot of clusters, right? And what, at least my understanding is, Kubernetes is a single cluster type of solution. Like, what challenges did you face, like when you had so many clusters and you're running Kubernetes, like the network security or whatever it was?
Every technology comes with its pros and cons. Kubernetes is no exception. So while it provided an easier way to operate in, more modular and simplistic way to develop your service, and faster, time to go to market is way reduced. as you can bring in more changes in a faster world. So the challenges were when we started, the services, Kubernetes can schedule, deschedule, your zonal, regional management. So single cluster was a no-go from beginning itself. So we realized that there are various factors like for example, we needed to treat clusters as immutable. I mean that was a later concept that came in, but to bring the right set of availability for our services for our customers, we wanted to go with multi-cluster. In fact, to top that, we wanted to have multi-region and then different availability zones as our cluster. So that's how we divided managing Kubernetes clusters from one to more than one cluster.
In regards to that, like, were there any like policy type of challenges you faced during this multi-cluster type of environment?
Like I think I'll probably touch base a little bit on because Box uses Calico extensively.
Okay.
And Calico had been our partner to provide the zero trust. Whatever we do with respect to Kubernetes clusters, Calico is a key component there. So when we went with multi-cluster management, policy, applying network policies became a challenge. Essentially, when we create different network policies, one was like, okay, you have to have similar services run on all those clusters. In fact, you may have endpoint in one cluster be able to discover endpoints in other clusters. So there was a constant toil in terms of managing those policies, creating those policies, making sure those policies gets applied across the clusters, and essentially exposing those policies to the service owners rather than keeping it with one team with which is highly dependent to manage those policies. So we realized those challenges, worked very closely with the Tigera team to enable us with the flexibility to operate with the right policy management model.
How did you basically address these challenges? I know Calico played a part, but like what happened on the ground, right? Like anything along the lines of like a GitOps model or anything you guys?
Yeah, absolutely. So one core principle that we, as an engineering-driven organization, we operate in is auditability of everything we do in our infrastructure. That applies very well to the policies that we manage. We started initially, way back in the days, applying the policies into the systems. We realized that we are losing the trail of who is doing what, and when the policies are changing. And that was one of the core compliance requirements. So you would be able to give a full trail of things that has happened in the system. So we adopted GitOps model very early on. We created kind of an infrastructure to manage the policies end to end. So we use Kubernetes, labels, and then policies are defined, in a centralized place with access to services that who can come in and write policies in a simplified, format, declarative language like YAML, and then we have an internal system that will take those and create in a format that is understandable by Kubernetes as well as Calico in this case, because we use Calico. So in a nutshell, you can say that, okay, there is a centralized place where all policies live in, that provides a view of what is applied in which system. And then we separate it by clusters, and we run the policies periodically as the changes happen. As the changes merged into the Git repos, then there is an automated system that takes those policies and applies into the right set of clusters. And the services uses those labels, and then based on those labels, those policies enforcements actually happen. So our core principle, like you asked in the beginning about zero trust, we start with a denial approach. Everything is denied. And then based on the policy enforcement, things get applied slowly.
So with GitOps, you were able to deploy policies, right? And now as there are so many workloads which are coming up, right? Services which are coming up, they're going out, right? And the policies are being mapped and everything. Did it open up a new set of challenges for you? Because I assume because you are on the leading edge, you were leading edge on cloud native, you were leading edge on Kubernetes, you were leading edge on zero trust. So when you are basically on this journey, what things will you share with the listeners here? Like, what is the next thing which came up?
The GitOps model worked pretty well for us. Just to add a little bit of more complexity there, we use federated endpoints because we use a multi-cluster. So essentially, we wanted endpoints from each cluster to be able to discover who they need to be talking to, and apply those policies themselves on the native clusters. So we use granular level network policies. We use host endpoints. In a co-located environment, self-managed clusters, we also use BGP. So there were already a set of complexities and problems that we solved through automated policy management and federation. Now, when we started our journey to public cloud, and as more and more services got into the Kubernetes model, we found the difficulty of managing that system overall. And writing a policy needed the knowledge. Like, though we simplified it with industry standard declarative languages like YAML or JSONet, still there was a little bit of a learning curve because the code didn't live alongside the code of the service owners, like what they are used to write day in, day out. So the dependency increased, the time to go into clusters was delayed a little bit. And then most importantly, we didn't want service owners or the workload owners to be writing wrong policies, and then you end up in having a breach to your actual zero trust mechanism, right? So that's when the thought came in: how do we simplify not just users' experience, rather you stay compliant to all your security requirements and make it one level up in terms of automating and having those policies dynamically generated.
Can you explain this dynamically a little bit to us?
Yeah. So it's operating as we speak in the background. So we knew that service workload owners already are writing their workload manifests in terms of how they want to deploy, what are the replicas, all those different fun stuff that they do on Kubernetes. And we wanted to enable the similar self-serve capability to them. So if I'm a workload owner, I know what are the dependent components or other downstream, upstream dependent services that my workload depends on. All we did is like we took the worry of policy from their mind away. Rather, we said, okay, as you write your code, you say, okay, I'm dependent on workload Y, workload Z, and we talk on port X, port Y. That's again standard definition that is inherited from our centralized config management, which is some sort of kind of, you can think of like a service naming. So that's all they do. And then once they do that, we created a Kubernetes controller, which will take those informations and create a formatted policy and apply it into the clusters. So
how much has it helped you? Sorry, completely.
Yeah. No, it actually it helped a few areas. First, we continued to because every code is in GitOps model, so we continued to maintain the auditability, compliance requirements. Second is we didn't have to create policies manually, in the sense like even though somebody has to go write in a GitHub file, still somebody has to go write. So we eliminated that. So nobody has to write the policies. Nobody need to understand how Kubernetes network policies needs to be written. That's hidden from the customers. And then when we build a system, you eliminate the possibility of error in writing policies. So essentially, the policies live alongside the application code. So it's very easy to say which application is dependent on whom. And then we use that information to build a dependency graph, easily to say like, okay, service X is dependent on service Y, Z, and so on, which was not possible before. And then this also helped in maintaining our zero trust posture. I would say rather it enhanced it further, because the underlying controller had the ability to dynamically scan through and say if anything is written wrongly, or there is enough adherence or not.
Got it. This is awesome. Okay. So in the end, like as you have already talked about the results, so I think so I'm pretty good with it. But I think so we are coming at the end of our session. So would you like to have some parting thoughts here?
Couple of recommendations, like from what we have learned, operating Kubernetes for years. I think it's important to this, when we operate Kubernetes comes with constant changes, right? So having the right set of technologies, like using something like Calico, which comes handy in terms of providing you the ability to write those manage, maintain policies through APIs. That is an awesome facility, so we don't have to build anything homegrown. And the ability to troubleshoot problems. So network is one of the critical areas when you go into different clouds. Like there are many pieces, like, back in the days when I used to manage data center related teams, if you can't find problem anywhere, you blame it on network. So that was the theory so when it comes to network, you have zero trust, you have compliance, you have policy management, and most importantly, you have to make your customers stay satisfied. That means time to resolve any issues is important. So this centralized policy management using GitOps model, using the Kubernetes native technology like controllers and operators, and using Calico Tigera multi-cluster management, which gives you the visibility and in terms of observability of those policies and services, how they talk to each other, is a great way to solve some of those challenges.
Thank you. Thank you so much. And definitely, I can say I learned a few things today, right? Like, first of all, Box is leading edge innovator on technologies itself. Like, you talked about the kubectl on a new cloud native side, the immutable concept, and then on also the security concept like zero trust. So thank you so much, Tapas. I hope everybody who has been listening and seeing this session enjoyed this session and learned about how they can also address their networking and security policy issues in the multi-cluster environment. Thank you. Have a great day.
Cloud-native applications can't be secured with the traditional security tools. You need a more active and granular level of security. Calico Cloud is an active cloud-native application protection platform that detects, prevents, and mitigates breaches in cloud-native applications. Let's look at how to secure your cloud-native environment at build time with Calico's container security. At build time, we want to make sure that images that the development team provides are clean and without major vulnerabilities or misconfigurations. All image registries are auto-populated and continuously scanned by Calico's scanning engine. I can also manually add new registries. It's very easy for me to see the results of the last scan from the scan results page. Pass-fail is color-coded with specific scores. Details about each vulnerability that impacts each image are available on the right side. I can control which images can be displayed to my environment using admission control policies. I am only allowing images with pass or worn scan results. I've also enforced an upper limit for the age of a scan result. Now, if any application developer attempts to deploy an image that doesn't pass the security criteria, it will automatically be blocked. Once you have the admission policies in place, you may come across a situation where the application developer is telling you that a particular vulnerability does not impact their code and the way in which they are using the affected library. In this case, you need to create an exception. Calico Cloud offers a number of options to scope the exception to a specific image version, any version of this image, or any image. In addition to scanning and assessment of images, I must ensure the Kubernetes environment is also secure